Hello folks, let's come to the part 5 video of this miscellaneous exercise and let's quickly check the questions which were left to do. We are now taking the problem number 12. It is defining A star B. Where is it defined? Problem number 12, it's defined, star is defined from R star R, R cross R to R, and the operation O is defined from R cross R to R. They are defined in the way it is being given in the board. You have to check commutativity, associativity, and at some places distributivity also. So let's do that and let's see how it is. Let's see what is one operation will distribute over the other, which is distributing over which. All that we will find out now. So first we will look out for star operation. For star, first we'll check for commutativity. Right. A star B we already have. Let's consider B star A. B star A. So that is going to be modulus of P minus A. But we know that modulus of modulus of A minus B is the same as modulus of B minus A. Like that, A star B will become equal to B star A. So like that, star will become commutative. Yeah. Then we will look out for associativity. Associativity. Consider A star B star C, out of which A star B is going to be modulus of A minus B star C, which means modulus of the first term minus the second. And if you look out for A star, see, actually this doesn't hold true. So because it doesn't hold true, more than all this, I think it's better we take a counter exam. It's more clear. Yeah. Star is not associative. Okay. By example given, 2 star 3 star 4, for example. Through 2 star 3, by formula it is modulus. So it will come to minus 1. So modulus will be 1 star 4. So by formula 1 minus 4, so minus 3, but that will be 3. Then let's check, and let's check 2 star 3 star 4. We could do it the other way. This way also is okay because it's not holding true enough if we give a counter example. So 2 star 3 star 4 means 3 minus 4, which means it's minus 1. So the modulus is going to be 1. Now 2 star 1 means 2 minus 1. So by modulus, and that is going to be 1. So here 3, here 1, two different values, right? Therefore 2 star 3 star 4 is not equal to 2 star 3 star 4. So star is not associative. It's not associative, but at the same time the O operation is not like that. It is it does hold true. So let's check for O. This is for commutativity. AOB we know, so BOA let's consider. BOA will be B, the first element. Yeah, that's how it's defined. But therefore we'll see that AOB, which was A, is not equal to BOA, which is B. So therefore O is not commutative. Here also you could take a example and do that way also, it's okay. Otherwise we could do it like that in general. Associativity. Let's first consider, I think we'll run short of this, A star B star C. AOBOC. So AOB means A, first element. AOC, so, and OC, and first element A, and AOBOC, first element B, first element A, so it's the same. So therefore you have AOBOC is equal to AOBOC. So O is associative. Okay. Now distribute it. Okay. To check, A star BOC is equal to A star B or A star C. LHS consider, right? A star BOC means first element B, right? BOC means first element B, and star means it is modulus, right? Now RHS. A star B, A minus B, O, A minus C. O means first element, A minus B. So LHS equal to RHS. See, incidentally, therefore LHS equal to RHS henceforth. Right? They had asked us to prove that. But to check, AOB star C is equal to AOB star AOC. So LHS. Here LHS. See, AO B star C, because it's put in the bracket, it will be B minus C modulus. But AO, anything is going to be A, first element, right? Then RHS. AOB means it's a first element A, star, first element A. So A minus A, which is 0. LHS is A and RHS is 0, not equal, so not true. Therefore, LHS not equal to RHS. So does not distribute over star. Okay, so that's about the distribution. That's about the operation. Just wonderful to know how it is. Okay, then we have again the set X, and then you have the power set of X, and on that power set of X you are defining a binary operation star such that A star B is A minus B union B minus A. If that is the case, they are asking us to find out what is find out the identity element. I think that's what they ask us. They ask us to find the identity element. You check that empty set is the identity element, and which could be invertible. So let's do it right away. Consider A star B equal to A, which is equal to B star A. Therefore, A star B equal to A means what? A minus B union B minus A is A. Just imagine, A minus B union B minus A is A. Something like set A here, set B here. A minus B is the set, B minus A is the set. And the union of these two is only this set. How can it ever be possible, right? But it can be possible if B is not existing. Suppose if B is not existing, 0 or empty set. If B is empty set, then this will be A alone. A minus empty set is A. And empty set minus A, it's A itself. So A union A can become A. So this can be possible. Therefore, B is empty set. Similarly, B star A equal to A is also same way. B minus A union A minus B is A. That can be possible only when B is an empty set. Therefore, empty set is the identity element. So, now for invertible. Let A star B be equal to empty set, which is equal to B star A. Now, A star B is by formula A minus B union B minus A is the empty set. The union of two set is becoming an empty set, imagine. Star A inverse. They have asked us an invertible element, and according to invertible, it is A star A inverse is identity. Yeah. So yeah, that's right. So the union is going to become an empty set. How can it ever be possible? Union itself is going to be a bigger set, and that itself is coming as empty set. It's not convincing. So what can happen? That this can happen if each of these are empty sets, right? So if these have to be empty sets, A minus B is empty and B minus A is empty. Okay, what is the indirect meaning? That B will become equal to A in each case. That means the inverse is A itself, right? So therefore A inverse is A. Similarly, for B star A equal to empty set, we will get B as A, and therefore A inverse as A. So that's it. That's what they have asked us to show, that A inverse is A. In both the cases we have shown. That's how it is an invertible element. Now we are going to the next problem where they give us a finite set 0, 1, 2, 3, 4, 5, and they are defining the A star B like this. And they are asking us to find out the identity and inverse elements. So because it's a finite set, there's no harm in doing the composition table. You can do the other way also, but because it's a finite set, we can go for this so that you can pick things up really easily. So let's see, 0 and 0 plus 0 is 0, so that will stay as it is. 0 plus 1 is 1, 0 plus 2 is 2, 3, 4, 5. There also 0 plus 1, 1, 2, 3, 4 and 5. Now 1 plus 1, 1, 3, 4, 5, 6 will become 6 minus 6, 0. Then 2 plus 1, 3, 4, 5, 6 will become 0, 1. Then 4, 3 plus 1, 4, 3 plus 2, 5, 6 will become 0, 3 plus 4, 7 will become 1, 5 plus 3, 8 will become 2. 4 plus 1 will become 5, 4 plus 2 will become 6, which will become 0, because 6 minus 6 is 0. Then 4 plus 3 is 7, which will be 1, because 7 minus 6, like that. Then 4 plus 4 is 8, 8 minus 6 is 2. Then 4 plus 5 is 9, 9 minus 6 is 3. Then 5 plus 1 is 6, 6 minus 6 is 0. Then 5 plus 2 is 7, 7 minus 6 is 1. 8 minus 6 2, 9 minus 6 is 3, 10 minus 6 is 4. So this is your composition table. They ask us to find out the identity elements that we can check. Here, see, 0 star 0 is 0. Then star 1 is 1, 1 star 0. 0 star 2 is 2, 2 star 0. Then 0 star 3 is 3, 3 star 0. Then 0 star 4 is 4, 4 star 0. 0 star 5 is 5, that is 5 star 0. So therefore 0 is the identity element. You're getting back the element, that is why it's the identity element. Now you have to find the inverses, that which are the inverses. I think that's what they're asking. Let's see what they ask us. Show that 0 is the identity element and each element is invertible with so and so is the inverse. So let's see now, inverse of 1. Where do you get 0? 1 star 5 is 0 and also 5 star 1. Just check. 1 star 5 is 0, 5 star 1 is also 0. Okay, so it is the inverse. Then 2 star 4, you can check from the composition table. 4 star 2, 3 star what? 3 star 3 is 0. Of course, 3 star 3 is 0. So you have it always. That way you will have 1 inverse as 5 and 5 inverse as 1 and 2 inverse as 4 and 4 inverse as 2, 3 inverse as 3. So these are the things, and they have also told us that this is 6 minus A or something like that. So 6 minus 1 5, 6 minus 5 1, like that. Okay, and therefore A inverse is 6 minus A. That's what they have asked us to show. Could have done it in the other way also, but because it's a finite set, we can take the composition table, and that makes our work really easy. So that's all about this video. We're taking the new video with a new set of problems. Thank you.